Lesson 6. This lesson will show the user how to compute permutation where the order does matter and combinations where order does not matter using Excel. Permutation of objects of n objects taken R at a time. The definition: a permutation is an ordered arrangement of objects. The number of permutation of n distinct objects taken R at a time is NPR is equal to n factorial over the quantity n minus r factorial, where r is less than or equal to n. Here's an example. Each year, 33 race cars start the Indianapolis 500. How many ways can a car finish first, second, and third? Well, n is equal to 33, r is equal to 3, so we have 33p3, which is equal to 33 factorial over the quantity 33 minus 3 factorial. So here we have 33 factorial over 30 factorial, or 33 times 32 times 31 over 1, and we have 30 factorial over 30 factorial. Remember, any number over itself is equal to 1, so ultimately we end up with 33 times 32 times 31. So there is 32,736 ways for 33 cars to finish first, second, and third. Okay, using Excel, we know that n is equal to 33 and r is equal to 3. So I'm in A20. I'm going up to Auto Sum, come down to More Functions, and in the gray area, we want to type Permutation. And hit Go. And it gives you two choices. You want this P-E-R-M-U-T. You want that one. So hit OK. And if you notice in A20, it's right there. But in this gray box, the top number is 33, and the bottom number will be 3. You hit OK, and you'll see our number, 32,736. If you click that box, you'll see your formula. Here's the equal sign indicating there is a formula. So P-E-R-M-U-T, 33 is your first number. That's the number of cars we have. And 3 is the order of finish, 1, 2, and 3. And if you hit enter, you'll see the number 32,736. Our next topic are combinations of n objects taken R at a time. The number of combination of R objects selected from a group of n objects without regard to order is NCR, which is equal to n factorial over r factorial, and then n minus r factorial, where r is less than or equal to n. Example, a basketball team has 12 members. There can only be 5 players on the basketball court at one time. How many ways can the coach arrange a team out on the court? Well, n is equal to 12, that's your total members, and he needs 5 players, so r is going to be 5. So 12C5 is equal to n factorial over r factorial times the quantity n minus r factorial. So it gives us 12 factorial, 5 factorial, and 12 minus 5 factorial, or 12 factorial over 5 factorial, 7 factorial. You put that into your calculator, and you'll see that you get 792 ways to put 5 players out on the court. Okay, Using Excel for this problem, we know that n is equal to 12 and r is equal to 5. So I'm in A28. You can use any one of the cells that you like, but I'm using A28. I'm going to put an equal sign, which means there's a formula coming. We're going to go up all the way to the right on the ribbon, go to Auto Sum, come down to More Functions, and we want combinations. So I type the word combination and I hit go, and you'll see that we have two choices. You want the one that's highlighted in blue, and you'll hit OK. Notice in A28, it came up here, but in this box over here, the number, we want 12 because that's the total number of players we have, and there's 5 members of a team out on the court at any one time. Hit OK, and you'll see our number 792, and that's what we got in the previous example. So there's 792 ways a coach can put 5 players out on the court. This ends the discussion on permutations and combinations.